during the tsunami the affected parts, very badly affected, were the ones which is shown here in blue color. So all these places were affected, and a bit affected were this much, but it was not much, and this was really not affected much because it is in the shadow area of Sri Lanka. So this shows that this is the MS elevation, that is mean sea level. When the maximum water level comes, usually it may be somewhere here, mean maximum water mean maximum maximum high water line may be somewhere here, maybe somewhere here, it is only an approximate representation, but during a tsunami the maximum water level may be much higher, which means that it will run it will reach the land point somewhere here. So where it reaches, this is going to be the inundation height measured from the mean sea level, and the inundation distance is measured from this point to this point. This is very important. This defines the inundation height and the inundation distance. Run-up levels at few locations during the tsunami are indicated here. One is Chennai, then you have the Batikolo, that is in Sri Lanka, Maldives, then this Bandrache 12 meters, then Phuket, and that is at 4 hours. Okay. So this shows some of the video clips during that appeared in the TVs and in the internet, that how the propagation of the tsunamis in Penang, that is in Malaysia, then Indian tip of Indian Peninsula. You see that, so before the ingress so much of land was exposed, seabed was exposed, that is not the issue, that is not usually the case. So there were about 500 meters of land was exposed near Kanyakumari, and then you see that the waves reached almost the pedestal of this statue, and the splash hit even the head of the statue. Okay. I just leave this so that it gives an idea concerning how devastating was the tsunami. So you see the waves coming here, that is those are the tsunami waves. There are so many incidences that people got trapped under the near that area, all those things, but I do not want to go into all those details. So you see that here, so it reached up to the pedestal of this statue. Is it clear? Okay. But there were some other movies taken wherein you can see the water level going up to the head, but it was only the splash. And after this you see how the boats are moving and they go and collide with each other, and that has resulted in a huge damage to the fishing community. So now this is somewhere in Sri Lanka, and this is somewhere in Indonesia, Thailand. So these are so you can see the pumping of waves into the land. I will run it once again. So there are some casualty in both the locations, on all the locations there were some casualties. I am just showing only some clips because although I have all the other information, it is just to make sure that you have some kind of an idea. So you see the ocean water entering into the swimming pool of a hotel, that is in Sri Lanka. So you can also feel for the speed with which the water level was moving, right. So damages due to tsunami, this picture is almost all the glimpses of the damages that were caused along the Chennai coast are shown here. So you see the vehicles just lifted and floating, and then here is the coastal flooding. This is the coastal flooding, and this is the tip of Indian Peninsula, where you see the boats going and hitting against each other, got damaged. So here again a bridge, a nice bridge got collapsed, and then this shows at some certain locations where this is the red mark shows the level of inundation, the height of inundation. So again somewhere this is the city of Chennai, where you see the flooding in the Marina beach, and you can see the water level somewhere in Chennai. So you can see the whole thing. So the Marina beach imagery, tsunami impinge on the Marina beach, then effects of the coastline. So locations of tide gauges along the Indian coastline. So if you look at the Indian coastline, we have tide gauges all along the Indian coast. So during the propagation of tsunami, what happened, all these gauges, the tide gauges will certainly record the water level. But what happened we will see here. So this is Visakhapatnam, this is I think Cochin. So you see that all this blue arrow at the time of arrival. So time of arrival is this one, and the disturbance. So that before that you see all the nice smooth recording of the water surface elevation, but you see at the time of arrival of the tsunami, this has failed, that is it has stripped, that is the tidal gauge did not have the capacity of recording a water level beyond that. So I understand that the range of measurement of this was only 3 meters, and so that means the water level in these locations might be more than 3 meters at that point of time. So even Mormugao did not record at the time of failure, because probably this failed or it failed to record the level slightly more than what it is supposed to record. So apart from that, this is what happens. I have been telling you earlier that once a long period wave enters inside a harbor, then it is a big problem. So this is basically a long period wave. When it is when it has entered inside, the disturbance continues. When the disturbance continues, then the collision of the boats, vessels, all these things will take place, and that is going to be catastrophic. And this is how the oscillation will be very slow oscillation, but then this is good enough to snap the mooring lines and leading to other kind of damages. So this is a movie soon after the tsunami, that is in Nagapattinam. Nagapattinam is south of Chennai, where that was very badly affected area. So you can look at the kind of devastation. The boats which were supposed to be in the harbor are all on the berth, and this was very badly affected. So tsunamis affects coastal structures selectively, human life very severely, property very badly, coastal landforms selectively. So surface and shallow water fresh bodies, generally it was affected. Coastal flora also was generally affected, but not very severe, but surprisingly the animal life was rarely affected because they had the sense of knowing that something untoward is going to happen, a natural calamity. So there was not much of problem with the animal life. Coastal fauna here and there it was affected. So major impact in the foreshore, modification of the beach front, concentration of heavy minerals deposit as places, then breaches in the beach ridges, then flattening of foreshore and adjacent areas. Now we have done the post tsunami survey. So this is the map of Tamil Nadu. This is the affected area and we are somewhere here. This is the Indian map and we are somewhere here, and Nagapattinam should be somewhere here. Okay. So let me just show you about the Chennai area. Chennai area is somewhere in this location. This is the stretch for Chennai region. So we did so the Marina beach, one of the longest beaches in the world. So you see that this is the kind of inundation we have. The area inundated between Adayar, that is somewhere here, up to Kuam river. So this is approximately 2.9 kilometers and this is approximately, I think this 0.29 kilometers, 0.3 kilometers and this is around 0.5 kilometers. So that is the kind of inundation they had got. This map I believe it has been done by Anna University or one of the institute which is involved in the GIS and remote sensing, and some of these pictures have been borrowed from some friends. So you see that one good thing that happened was the opening of the river mouths, which is always a perennial problem of sandbar formation, which we have already seen earlier, but during the tsunami that was only plus point, that it got removed, and the toe erosion, that was one serious problem that took place during the ingress of the tsunami. So this toe erosion, because when it is retreating, when it is going back on the sea wall, on the landward side of the seawall, see these are all soft soil, it is only a sand. What will happen with the velocity is created, this will drag, and also there is some amount of drawdown here. So all this will all pull the sand inside and creating toe erosion, and there was a lot of damages to the sea walls, which we will see later. So this is in Mahabalipuram, a famous tourist spot, and this is how it looked during the tsunami from the balcony of a hotel. So where you could see the beach, now you see only waves. So effect of Mahabalipuram. So this is Mahabalipuram, a case study which we have already seen during our in the lecture on coastal protection. Now here during, as I said, there was water which is receded, okay, the water level receded into the ocean. So this exposed some of the relics. Century back there were some temples and other things which were which got sunk, okay, buried. So those were exposed during the tsunami time. So during this is a flat area near Mahabalipuram. So the sea water entered through the unprotected coast, and then there was some problems in this stretch of the coast. As I see, this is a major problem, one of the river which is draining into the Bay of Bengal, and it runs through the city of Chennai, and it is always a perennial, it has been a perennial problem for decades, that is a closure of the river mouth, leaving which is quite sad for the entire city of Chennai, because this is going to this is being served as a stagnant pool of water for the breeding of mosquitoes, and there are other associated problems. So this is always closed. Now during the tsunami you see that it is opened, and even the Adayar river was opened, as you can see here. A closer view of the Adayar river, always closed by the river sandbar formation, but during the sun it was opened. So we did the tsunami run up mark. So for example, we identified the coconut tree in one of the places, and about 500 meters from the shore, what is the setback here. So I will come back to the setback line later, because how close the people can put up the dwelling units from the coast. This is one important issue which needs to be discussed, because they say that you should not construct any building within 500 meters, but that rule cannot be really applied. So I will see the effect of all these things. I will show you all the effect of all these things later. We will discuss about the coastal regulation zone towards the end of the talk. So there are other locations where we had had a close survey, and one such location is something like this, where there were a lot of problems. Devanapatnam, there were about 80 to 80 casualties, and this also somewhere here also there are several casualties here. So this stretch of the coast is very important. So what you do is and this is a river, and this is also a river. The initial idea was to train this river, so that the sandbar formation is removed, and then both the rivers are free, so that they do not have the stagnation problem, and then the sandbar formations associated. So that is one thing, and then in between them have a transition groin field, and also associated with a bund like this, a seawall, with all these things are only a conceptual design, but the detailed design has to be worked out. This is only a conceptual design. So like this we had done several stretches along the coast. We have identified where exactly you need to go in for seawall, where you need to go in for training walls or groins, etc., and what were the priorities, etc. This is a major report that has been prepared. So look at this, when you have a flat beach as shown here, this is one case where it is, this place is called as Tirumullai Vasal. Tirumullai. So this area, so look at the road, there are a lot of casualties here in this location, and this is it has never occurred like this, never in history. So you look at this, because this being a flat beaches are very dangerous locations as far as tsunami is concerned. So you need to safeguard all those areas. So I allow this movie the clip to move on, so that because you again see a road, a permanent road, a metal, a permanent road now looks like a river, and I believe that this location, at this location you had the inundation distance was something like 2 kilometers, 1800 meters to 1.8 to 2 kilometers. So I allow this to move. In fact, there was a video for running for about it was running for quite some time, I think maybe 1 hour or 1.5 hours, and I just had a cutting of this. That was very sad, because the whole thing, see, once it was looking once a road, now it gives an impression that it is a river. Any of you have seen this? So now you get an idea, right, what was the 2004 tsunami, at least people who have not been staying near the coast. So this was one problem, but then again when it is receding, that is going back, it took away a lot of debris and other things and created a lot of problems. Madurai region is somewhere here, Madurai. Somewhere here, not the Park State, somewhere near Madurai. So some are again south of the Chennai region. You see what has happened. So this is another movie. This place is called as AALANTHAALAI. So wherein you see the continuous pumping of sea water into the ocean, and what kind of engineering solution you can really think of when you have such kind of a devastating force. So very difficult to really design anything for this. It is quite massive. Later we will anyway look at design, I mean the estimation of wave forces on vertical wall structures, etc. But I do not know how to deal with this kind of waves, what kind of real so continuous. Okay. So as I said earlier, so the bridge completely collapsed, the sea wall disturbed completely, then all the river mouths opened in this region, that is Vellar. Madurai region is slightly south of Chennai, no, far away, maybe about 300 kilometers, 400, 500 kilometers maybe. So you see all this opening of all the rivers, and this is one area where it was quite devastating. So this location is somewhere shown here in the Madurai region. So you see that there is this is the sea, and this is a canal, and this is a road, and this is all flat. Wherever you have flat beaches, it is very risky, but here this road is at an elevated level. If all these people living here had managed to run into this road, most of them they would have saved, because slightly beyond the road also there were some elevated areas. But what happened is, it was a pity that there is a canal here and you have a bridge, and when the water comes you do not know, you are running complete without any aim, the only aim being to escape, and all the people rushed inside and they lost the track, and many of them they got trapped in this canal. And this is the AVM canal, which was very much referred to during the period of tsunami, where they had a lot of people who got drowned into this AVM canal, and this entire area completely washed off. So this is the area where I said this is far away from the beach, where you see that about 5 feet of water has come in. So this is the bridge I was referring to. So the level is almost the same as that all through till the beach. So all these things have got eroded, completely damaged, and you look at this church building, entire church building has been damaged, and I believe the water went up to the ventilator of this church. Okay. So you can imagine the kind of a problem they would have faced. So what is the kind of solution you can think for this kind of a problem? So what we thought is, we had an idea, there is an existing jetty, we need to tie, because what is the guarantee that the tsunami is going to occur? in next 100 years, there is no guarantee. Whether it is going to occur tomorrow, we do not know, whether it is going to occur, whether if at all it is going to occur next 100 years, we do not know. So are we supposed to keep quiet, or are we supposed to spend money and do something? So this is a very important topic, a very important and very tricky topic which we need a lot of debate and discussion. So but our own idea was that we looked at some of the problems locally. So they have a jetty here, they have a jetty which they are not able to use because of a higher level and because of the disturbance, because it is open. If it is an open jetty, they cannot come and berth their vessels because the vessels will be in oscillation, and this is an area which has taken away about hundreds of lives. So what was thought by us is around 1 kilometer or 1.5 kilometers, the affected stretch needs to be constructed like this, having a seawall, but prior to that have a pair of breakwaters. The alignment is not 100% fixed, it is only a concept, we need to do the detailed engineering. So have kind of a pair of breakwaters, facilitate the usage of the existing jetty and enhance the livelihood of the local community, and then along with it have a kind of a structure similar to this or less expensive. This may be a bit more expensive, it can be less expensive, or just a seawall of curved section, etc. All those things can be thought of. Only they make sure that this top level is kept at least up to about 7 meters, so that they will not the inundation can be much less, and also have some kind of plantation, so that it can reduce the speed with which the water is moving in. So this is the retreat of the shoreline at Tiruchendur, that is again south of Tamil Nadu, South Tamil Nadu. So the seabed exposed, so this is the original scene prior to the tsunami on the same day. So you can just see, and all this area has been exposed now, okay. So this is yet another along the Tiruchi region, along the Chennai, I mean Tamil Nadu. So all this remote sensing imageries, you see that how it has inundated some of the locations at different places. So you see Chennai is here, and all these places are here, and some of the shielding effect. This is a place where you had a lot of damage. This is in damages in Nagapattinam. So for people who are not familiar with where exactly is Nagapattinam, please go into the Google and search yourself, it should not take much time. So huge concrete bridge girders got collapsed, and that is very much inside the town, thickly populated town, and some of these areas where they immediately thought of some kind of a plantation, but I do not know what is the status as of now. So some other damaged portion of the vertical wall, there is a vertical wall also which was damaged, I do not want to go into the details. So this is an area which is called as Kichankuppam, which was very badly destroyed, because many people, about 300 people lost their life, and then so we have suggested some remedial measures for this. And one of the another area where around the same location is the Velangani, famous Velangani church is there. So somewhere here is the church, somewhere here. So there is a road leading, and there are a lot of inundation here. So the idea is to dredge this Vellar river, take this sand, put it here just in front of the church, so that it is saving in case of event like the extreme flooding, it can save to some extent, act as a buffer. So you have the plantations and a sand dune here, and then have buffer blocks, something like seating arrangements, so that in the event there is a event like a tsunami, it has to go through the plantation, then over the sand dune, and then later on it will reach these buffer blocks, So buffer blocks are staggered, so the velocity will continue drastically reduce, that is the idea, and we make use of cleaning this river. So wherever we have the rivers adjoining there, this was a suggestion that remove or clean the river mouth. So some of the locations where the impact of the roads. Now we move on to the west coast. So as we have seen earlier, the east coast, because of the Sri Lankan island, the diffraction took place and hit Kerala. These were all the areas which were affected, that is in Thiruvananthapuram district, Kollam, Alappuzha, Ernakulam and Kanyakumari district. So all these places were, the thick ones shows the thickness, shows the intensity with which it has taken place, hit the coast. And here again the whole thing, the overall tsunami impact. So here this is the area which was very badly affected, and followed by these two areas, and then the Machilipatnam was one area that was affected and all other areas were not much, but they had their own impact. Moving on to Andaman and Nicobar Islands, GPS observation in Andaman and Nicobar, apparent movement of islands. They have predicted that the islands itself have moved in the direction as indicated by the magnitude as indicated in black colors. Maximum water level recorded in Andaman is as you can see here about 6 point almost close to 7 meters, 7.1, around 7 meters. Some of the cloud imagery is not clear, but here look at this. This is the one which was completely cut the entire island. The one piece of island is almost devastated by the and here again. So such informations can be obtained from the satellite imageries, and this is damage to the properties. And now we come to tsunami warning system. What is the kind of warning system you can have? See, one of the basic difference or the main difference between a normal wave and a tsunami is its wave period. It is period. As explained earlier, the wave period is in terms of seconds in the case of a wave, and it's in the case of a tsunami it's hours, okay. And in terms of length, it is in tsunami in the case of about kilometers, whereas in the case of a wave it is meters. So when you want to measure the pressures, you know that the pressures exerted by long period waves is more. We have seen, we have worked out problems also. So when a long period wave goes, there is an alarm, a trigger given to you. If you are able to have something in the beneath the seabed, as you see here, you have a pressure sensor here, and when there is a wave moving on the surface, the pressure sensor will sense the pressure due to the wave and sends it to the monitoring system, that is to the wave radar buoy, and from the buoy the signal is passed on to the satellite, and from the satellite it can be sent to the on land station. That wave that of pressure of this much has been sensed by the pressure sensor. So the pressure when up to about 30 seconds, if the waves are moving, you know what is the order of pressure that the pressure sensor pressure when near at the seabed for that given water depth, okay. So you know what should be the maximum pressure for a given water depth, but if it exceeds that pressure, then naturally you can easily suspect that it is something going wrong, maybe a tsunami or something like of this very long period has started propagating, and immediately this. So this is based on this principle, this DART system works, and so you have the wave raider buoy, you install a bottom pressure recorder, and then when there is a shake in the earthquake, and then so the signal is sent to the wave raider buoy, from which it goes to the satellite, and from there it sends a warning signal to the onshore station. This is the this is from the Pacific Tsunami Warning Center, where we have downloaded the system, and our system for the Indian Ocean warning Indian Tsunami warning system is also working on the same principle, and it has been proved that it works all right. So for all the details you need to go and check the website, and INCOI is the organization which is dealing with this. Now coming back to the forces, force categories available in the available codes, city county of Honolulu building code, that is Honolulu, that is in Hawaii, USA. So what are all the different kinds of forces that can occur during the ingress of a tsunami? Hydrostatic force, buoyant force, then hydrodynamic, surge forces, impact forces, and breaking wave forces. So along the Indian coast you see that there was a flotation, drag force due to run up and draw down, buoyant and loose objects like ships, trees, cars, and people. Then tsunami hazards second is the impact force of moving water. So you have 1000 times force of wind with the same velocity. So you look at this during a tsunami, during the tsunami none of the breakwaters etc. got affected, not much, the damage was not much along the Indian coast, along the the Chennai coast that was affected by tsunami. So but this one was affected, the complete breach was taken place in Andaman, that is because it was this was associated with earthquake plus the tsunami, and that is the reason why you have, because when you have a moment of tsunami it is only the static build up of the water which can really sustain, but if it is some sudden outburst, if it is moving in the if you have an obstruction in normal to the direction of wave propagation, normal to the propagation of the tsunami, then the whole building will collapse, you understand. So now this is flood and submerged with water, submergence, cause of because of so much of water, sea water entered the buildings etc., where you have buildings or industries, factories etc. So you had the short circuit taking place, and then because of that a lot of people died because of this problem. Then the tsunami undertow and scouring, as you can see here, look at the devastation effect of this building, the whole thing is toppled, and you see the returning water makes scour. This is only an example, there are several buildings which suffered scour and ultimately collapsed. Scour need to be addressed in tsunami design aspects. Foundation may be fully exposed, pore water pressure can increases uplift, that is another problem. Return flow velocity drags down structural components. These are the effects due to the scour taking place. For rubble mound structures you may need to provide filters, drainage systems, and proper store systems, which we have already discussed in some of the earlier lecture. Then 4 basic site planning techniques to reduce tsunami risk, that is as per NOAA, that is avoid inundation areas. So that is one area, but if it is like this, you have the structures only on piles, do not have any obstruction, solid obstruction. If you have solid obstruction you are in for trouble, or you have buffers as shown here, some elements, so that it will reduce the run up, and also you can streamline your structure, like streamline which is quite expensive also, or you can have block walls as shown here, like crown walls in the case of breakwaters. So some of these aspects are you just have on piles, as I have said earlier. So that will reduce the forces. This is tsunami proof housing, wherein you see that it is supported on piles. Tsunami proof power plants, example the Kudankulam nuclear power plant, which was being discussed for several weeks or months, and so this has been I am just touching only from the technical point of view, and I have not done any work on this, just whatever has appeared in the public domain I am just sharing it with you. So this has been built on the sea coast like any other electricity generating station, including the coal fired plants. It is well protected from a possible rise in the sea level by locating the entire plant site at a higher elevation. The safe grade elevation of this KKNPP site has been kept at 7.5 meters above MSL, and a shore protection bund has been constructed along the shore to a height of about plus 8 meters. So this is the view that has appeared in the Hindu, wherein this is the let us not go into the complete details. So now this is the reactor point with the level of which is plus 8.7, the level of the pump house is plus 7.65. Tsunami of 26th, that is the worst occurrence, that could be treated as a 1000-year flood level. Tsunami level is treated as 1000-year flood level. So that is coming only here. So still you have so much of buffer. So absolutely safe, there is no problem. Okay. So reduction of tsunami flow velocity you can decrease by having like this, or by green belt, as we have already seen. This is a view of having a green belt, but the density is not much, probably they are still planning it. So they use prevention of loss of life the topmost priority, then radio phones, public address systems handled GPS, all these things can be used. Then no system in the past, present structure and facility, seawall and breakwaters, we resort to only the structural measures. Now the future should be green belt with or without structures. That is the reason why I showed also the research studies on the green belt. Okay. So suggested steps for the effective management after tsunami with particular reference to coastal erosion. Enforcement of CRZ guidelines. CRZ guidelines is nothing but the coastal regulation zone. So there are some guidelines which we have to adhere to, should penetrate through the grassroots level. So everyone should know what is CRZ. So relocate habitation from low lying coastal areas to higher level landward, assess the damages to the coast due to tsunami and perennial problems of erosion, and identify the location along the coast for bioshields. For example you can think of casuarina or mangroves preservation. Mangroves preservation is very important, and this can be a long term solution and can also be called as, and is also a soft measure. At locations where beach width is narrower and the sand available in adjoining coast stretch of the coast, artificial nourishment along the coast, this is however always not possible, but it could be thought of. Only in case of any of the above two methods, that is either the plantation or the artificial beach nourishment is not possible, we should really think of structural measures, because structural measures we have enough knowledge, we can do the structural measures, but try to have the structural measures as a last priority. Vertical walls should be constructed only at locations where the land or property is extremely important. Further, in case of vertical walls, although the wave run up may be less, there are problems like enhancements cover leading to uncertainty in its stability. The forces exerted by waves and tsunami are high if they are directly exposed to them. The toes of such structures has to be properly protected, has to be properly designed and executed. Sloping walls on the other hand will gradually dissipate the energy, that should be the criteria. Against tsunami it is suggested to provide crown walls, vertical shape or other shapes as we have discussed earlier in one of the lectures. Hard measures are construction of sea wall with or without berm, preferably the first option, groin field or offshore breakwaters. The last option is comparatively costly and difficult to construct, that is the offshore breakwaters. But now I have earlier said that offshore detached breakwater with energy converters can be one possible viable proposition wherein it can serve as coastal protection as well as for extraction of wave energy. Combination of seawall and groins for tsunami, and then finally the sequence of construction is extremely important when you are planning for a coastal protection measure. So CRZ, coastal regulation zone, I suggest you check the net for, just put coastal CRZ, this itself will take you to all the details. There are basically 4 zones: CRZ1, sensitive and intertidal, consisting of areas as ecologically sensitive, that is ESA. So that is zone stretches of the coast where mangroves, coral reefs, turtle nesting grounds, etc. These are all coming under CRZ1. CRZ2, urban or developed municipalities, panchayats, etc. with population greater than 1000 per square kilometer, heritage archaeological areas, ports, harbors, mining sites, atomic power plants, etc. All these things come under CRZ2. CRZ3 is rural undeveloped, no development zone of 200 meters in the rural areas, will help fishermen for drying their nets, fish, etc. So and then finally for islands they have CRZ4. So actually according to this it was in 81 the then Prime Minister Indira Gandhi has advised the coastal states to permit no development within 500 meters from high tide line, but not many maritime states really followed this. If you see, you can see so much of development that has taken place within that 500 meters from the high tide line. So I would like to take some time in acknowledging all the people. I have liberally taken from NGRI some of their slides, NOVA, NRSA, Survey of India, Hindu, several websites, USGS, colleagues, friends and students.